Hi everyone, welcome to part 4 of my VLSI project series. In the last post, I shared how I extended my CMOS ring oscillator to a 5-stage design and achieved around 5 GHz. But now, without using a voltage control oscillator, I pushed the design further by tuning the input pulse delay and successfully achieved a 10 GHz oscillation frequency using the same 5-stage structure. I used LTspice with 45nm PTM CMOS models and adjusted the pulse timing to 0, 1, 0, 5 pico, 5 pico, 50 pico, 100 pico, as I mentioned here. You can see here, and this reduced the per stage delay to 10 picoseconds, enabling oscillation at 10 gigahertz. Coming to the performance highlights, I can show you practically by simulating the software. Wait, yeah, this is the schematic, and coming to the performance. As you can see here, 10 gigahertz frequency. Coming to the performance highlights, average current is approximately equals to 32.83 microamperes, and peak current is 76 microamperes. And on average, power consumption is approximately equals to 32.83 microwatts at 1 volt power supply. The output waveform stayed stable and clean, proving that with precise delay and control and sizing, CMOS ring oscillators can operate well into the gigahertz range. Thanks for watching. If you are into the VLSI, LTspice or 5 GHz, 5G hardware design, feel free to share your thoughts. Thank you. Jai Hind.